Everyone, this video we will be talking about rational functions and rational expressions. So far we have learned about functions, we learned about factoring, and we will be using all of those in the development of this particular idea. As a motivation, I just want to recall or remind you the definition of a rational number. So these are, you know them as fractions, right? So basically these are numbers of the form P over Q, right? For example, 1 over 2, 2 over 3, pi over 3, 3 over pi, 7 over 9, etc. So a rational number has two of these components, which are called the numerator and the denominator. Okay, so taking that as an inspiration or as the starting point, a rational expression is basically a fraction containing a numerator and a denominator. As such, for example, you may have 1 minus 2x over x plus 2, or even 1 over 10x, or x plus 2 over x minus 1, etc. So that would be a rational expression. A rational function is basically, it's a rational expression written as a function. Meaning, if I say, for example, that f of x equals one of these, let's pick that one, x plus 2 over x minus 1, then writing it in this form with an equal to sign makes it a rational function as opposed to being just a rational expression. So for example, here is a rational function. Now since it's a function, you can be asked to evaluate the function, and evaluating the function, we know, is essentially replacing x by that value. So I have 120 times 20 over 100 minus 20, that's 120 times 20 divided by 80. 20 goes into 80 4 times, and 4 divides 120 to give me 30. And f of 80 is 120 times 80 over 100 minus 80, which is 120 times 80 divided by 20, which divides this 6 times to get 480. Okay, so what is happening is, here I observe that this is increasing, right? And that kind of makes sense because look at the denominator, 100 minus x. If x is more, then 100 minus x is smaller, right? And when you divide by a smaller number, you always get a larger number. Now, in the above example, you can also be asked to find the domain of these rational functions. So what you have to recall, firstly, what is domain? Domain is the set of possible inputs, right? And inputs are represented by the x values, which means that to find domain, what we are looking for are problem points, right? So the problem points that we know right now are values of x that cause division by 0 and values of x that cause square root of negative numbers. So these are the two things that we have been looking at so far. Basically, we want to keep an eye out that given a function, it should not happen that there's a division by 0 or a square root of a negative number. So if I look at this function that is given to me right here, the first thing I notice is, well, there is no square root, so I don't have to worry about that. But there is a possibility that this denominator becomes 0, right? And this denominator is 0 if 100 minus x is 0 or if x is 100. This means that this has to be removed from the domain so that the domain of f is all real numbers except 100 or negative infinity to 100 union 100 to infinity, or on the number line that's 100, you have everything else to the left and to the right except 100. And you cannot have 100 because that causes the denominator to become 0. Now let's look at another example. So this is also a rational function. To find the domain for this rational function, we again make sure that check when can the denominator be 0, right? Because that's what we are trying to avoid, which means this can happen when 2x squared minus x minus 1 is 0. Now this is not as straightforward as the previous one. However, this can be solved by factoring. Okay, so to factor this, I'm looking for two numbers, right, whose product is 2 times negative 1, that's negative 2. There's only two possibilities, 1 and negative 2, negative 1 and 2. For the first one, the sum is negative 1, and the second one, the sum is 1. So that's going to work. So this becomes 2x squared minus 2x plus x minus 1, 2x, x minus 1 plus 1, x minus 1 equal to 0, equal to 0, x minus 1, 2x plus 1. What that gives me is either x equals 1 or x equals negative half. Now remember, these are points that I have to be removed. These have to be removed, which means that the domain is going to be negative infinity to negative half union negative half to 1 union 1 to infinity, or you can say all real numbers except negative 1/2 and 1. Let me move this a little bit. Or you can also say, or you can also draw the number line and say this is negative 1/2, this is 1, we remove that, and the input can be anything less than negative 1, less than negative half, more than 1, or between negative half and 1. The only values that are not possible are 1 and negative 1/2, because for those values your denominator becomes 0, which is a problem. So that's just a brief introduction to what rational functions are. And when you find rational functions, basically you can do the same things as we have been doing so far. That's evaluating functions, finding their domains. Now, just as with our progression with regular functions, the next goal is to understand how to combine these functions. So in the videos that follow, we're going to learn how to simplify them, how to add them, subtract them, multiply them, divide them. That's going to be the goal for this week. Okay, that's the end of this video. Thank you.